So C prime of x, the cost, the derivative of the cost, the derivative of the revenue, the derivative of the profit. These are just rate of changes, right? The rate of change of cost, revenue, and profit, respectively. But they're also called marginal cost, revenue, profit. So when you see the title, for example, right here, marginal cost, they're giving us the cost function. And they're asking us la, 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 la. In other words, first, find the marginal cost, which is C prime of x. So let's start with this one, and then you choose the next one. So 47. We are given C of x, which is 100 minus 50 e to negative x. The cost is in millions, okay? I'm taking notes. X is the number of houses, so x units. Good. Now, they're also giving us the graph. Fine. Find each of the following. In part A, they're asking us to find the marginal cost, which is the derivative, and then evaluate it at 0, evaluate it at 4, and then find some limits. So let's take a look. Okay. So can anyone give us an idea of how to differentiate 100 minus 50 e to negative x? How will you start? Please.
Would we divide both sides by 50?
So we're only differentiating this function. It's just C prime. Very good. This is not C of x over x, which is the average cost. So this is the average. Very good point. So to differentiate these two functions, this is the average cost, and then we may be asked to differentiate it and find the rate of change of the average cost. This is a totally different function. Here we are given the cost, and they only want us to find the derivative. So let's find the derivative of this. Very good point. Not to make sure that these are very clear. Two different functions. Good. So can anyone differentiate this for us? And I'll put it here. Can anyone differentiate this for us, please?
Is it negative 50x?
Negative 50. And now we differentiate this. E to a function prime. E to a function prime is e to the function times the function prime.
Is it e to the negative x times negative 1?
Good. I saw Devin wrote it. Good. So then C prime of x equals 50, because when I multiply these two, e to negative x. Good. So we got the answer to part A, part B, and part C. In part B, they want us to find, where is it? C prime of 0, C prime of 0, and then C prime of 4. Round to nearest 1,000. Okay, fine. So C prime of 0 is very easy to determine, but C prime of 4 is not. So can anyone give us the answer for C prime of 0? C prime of 0 is? Please. Anyone? When you plug in 0 in C prime, what do you get?
Negative 50.
Careful. any number raised to 0 is 1, as long as a is not 0. 0 raised to 0 is not 1. So this is a number raised to 0, which is 1. So then the answer is 50, and it's in millions. Okay? Good. For C prime of 4 is a different story. I'm going to use the calculator. I'm going to share my screen and plug it in. So you know my style, I always like to see the function plugged in. So this is 50 e to negative x, and you know me, I like my parentheses. And then all I have to do is just plug in 4. So when I plug in 4, I got, and they want thousandth. So I got 0.916. Now let's establish the measurement unit. What is the measurement unit? Say it again. The rate of change, like every derivative, must have 2 measurement units. Mandatory one coming from the y value and one coming from the x value. Mandatory 2 measurement units. Like the rate of change. I cannot drive at 50 miles. I drive at 50 miles an hour. And the same thing here. So this was 50 million. Let's read the question one more time just to make sure, because I missed that myself. So the cost in millions of dollars for is given where X is the number of houses built. Okay. I couldn't hear you. For some reason, is it my...
Would it be houses per year?
So this is first. So first of all, C is in millions. It cannot be houses per year, because C is in millions, right? So the rate of change of C with respect to X. Is that clear?
Yeah.
So it's 50 million per $50 million per unit. But it doesn't make a lot of sense as C prime of 0. So the year works in the number of houses built. Okay, so C prime has to be the measurement unit of C over the measurement unit of X. There is no other, I'm sorry, right here. So there is no other possibility. So the rate of change is the measurement unit of C, which is in millions, over the number of units per unit, not per year. There is no discussion, no, we're not talking about years here. So when they produce nothing, I mean, when they build 0, that's what C prime of 0 is. So the rate of change, it's their cost. It's their initial cost. If they produce nothing, that's that's their initial cost. Now at 4, so this is in millions. So this is 916 0.000 per unit. Maybe they meant something else, but they are saying that x is unit. So if there is an error in the problem, that's a different story. But once they say unit, it has to be unit. It's the measurement unit of y over the measurement unit of x. There is no discussion there. Okay, and part D, I think there is one. Okay, yes. Find the limit as x approaches infinity from c of x and then from c prime. So let's take a look. So the limit, so this is D. Limit as x approaches infinity from c of x, which is 100 minus 50 e to negative x, and then the other one as x approaches infinity from this one, e to negative x. Perfect. Okay, remember what we do. So we cannot get away from limits, although we discussed them in chapter 1. So first of all, we have to look at the initial assessment. As x approaches infinity, I want to know what happens to this. Because this is fixed, I need to establish what this means. So remember, is there another way? I'll come back over there. So is there another way of rewriting e to negative x? Is there another way of writing e to negative x? Anyone remembers? E to negative x.
E to negative x times negative 1.
1 over e to the x, right? Here's the formula. A to negative n is 1 over a to the nth power. So if that's the case, when x approaches infinity, what do you think happens to this number in the denominator? Where will this number go when x approaches infinity? So e to infinity. What do you think? Where will e to infinity go? Not the 1 over, just this piece. Where will it go? E to the second power equal the 10th power equal e to 10,000, e to a million. Where will it go? Of course, it's all positive, but where will it go? What will this approach as x approaches infinity? Just take e to the 10th power to 10,000 and see what you get, or more. The calculator cannot even calculate that probably after a while. So where do you think this is going? When x approaches infinity, e to infinity, where will it go?
0.
It's so big that I cannot even mention it, right? Just take e to 10,000. I don't think even the calculator can calculate that.
Not an error.
Of course, because it's so big, it's not passable. It cannot even calculate it. Even to 100, it may not even calculate it. It's 2.6 times 10 to 43, to power 43. So, just this piece, where do you think it's going again? E to infinity. Please. It's such a huge number that we don't even know what it is. But now the question is, where is 1 over infinity going? Where will this go? I divide $1 by 10 million people. When I get to your door, how much will be left over?
Infinity.
So if I have a piece of pie and I want to divide it into 2 million people, And when I get to your door, how much will you get from this pie? I start in India, and then I go to China, and then I come to US. How much will you get from this pie? I have one pie and I want to share it with 2 million people. How much will you get? Is it clear why it's 0?
Yes.
Perfect. So therefore, the discussion was about this. So this approach is 0. So then, when x approaches infinity, this approach is 0. So then what is the limit? Please, anyone? What is the limit? Say it again.
0.
How much is 100 minus 0? Good. So let's move on to this one. We already established that when x approaches infinity, this approaches how much?
0.
Perfect. Excellent. So then the limit of this is
0.
excellent. 50 times 0 is 0. So let's take a look at the limit of the function because the graph is here. Look at this. So the function starts here at 50 because when x is 0, 100 minus 50 is 50. It increases till a certain point, till increasing, and it's continued to increase all the time. But it gets closer and closer, closer and closer to 100. And that is the horizontal asymptote. Now the rate of change as x approaches infinity. So as we produce more and more and more and more units, we build more and more and more homes, the limit of the rate of change of cost with respect to number of units will approach 0. Okay? In other words, the rate of change will not change. After a certain time, after a certain number of units, it will not change. The rate of change will stay the same, 0. Okay, so let's take a look at something else. Do you want to look at the growth of a retirement fund? Do you want to look at depreciation? You want to look at medication concentration? Okay, so let's look at another problem and move on.
We do 53.
Yes. Where is 53? Perfect. Medication concentration, 53. Perfect. And that is on page, where is 53? Is it on? Yes, 211. Good. So we're given a function c of t equals 10 t squared e to negative t. So now let's read. The concentration C in parts per million, so ppm, of a medication in the body t hours, so t is in hours. Good. After ingestion is given by the function. We wrote it. Find the concentration after 0, 1, 2, 3, 4, and 10. So part A, C of 0, C of 1, C of 2, C of 3, and C of 10. Okay, we are going to graph the function on the interval 0, 10, that's fine. And part C, find C of 5 and also C prime of 5 and explain what those values represent. Fine. Perfect pick. Good. So, of course, I'm not going to plug this in. Well, obviously, when t is 0, c is 0. Because this is 1, this is 0, this is 10. So it's 0. So I'm not going to plug anything in repeatedly. I'm just going to put the function in the graphing calculator. So let's put the function in. So ny equals, clear. So 10 t squared and e to power negative t, and that's it. I check, is this correct? Yes. So now I want to plug in 1 and 2 and 3 and 5 for the last question and 10. Good. So I go back and highlight, although it's very clear. So 3.68. And this is ppm. And then the next one is 5.41, also ppm, parts per million. And then 4.48 ppm. And then I'll copy the 5 in here. And the last question, C of 5, 1.68 ppm. And C of 10, 0.05 ppm. Good. Now I'm also going to graph the function as they wanted us to do on the viewing window, and they want 0, 10. Okay. They're not telling us other than that, just they said 0, 10 for t. So we'll see in a moment if this is enough for y. It may or may not. So I'm just gonna leave it alone for now. And let's graph. Excellent. So you see the graph starts as expected at 0. And then at 1 is, so at 1, did I use a 1? Yes. Okay, at 1 is 3.68. The scale here is 0 to 10. 1, 2, 3. Yes. Okay, perfect. Then at 2 is 3.68. I'm sorry, at 2 is 5.41. 1, 2, 3, 4, 5.41. Yes, I see it. And so on and so forth. And then it approaches 0. Gets closer and closer to 0. Perfect. So that's the graph. Now, the last part is asking us to determine C prime of 5. Well, I cannot determine C prime of 5 before I find C prime. So let's determine C prime, which is the marginal cost, if it's the cost, or it's just, if it's another function, it's simply C prime of t. Good. So then what procedure, what formula, what rule we apply here for 10t squared e to negative t?